Welcome to this demonstration of the autonomous SAN. We will show you how the Brocade fabric can self-heal using fabric performance impact notifications, in this example to a Red Hat Enterprise Linux server, by sending notifications to the HBA that then forwards the notifications to the MPIO layer in order to avoid performance impact on the application when there are link integrity issues. Here you see the diagram for our setup. Our host is connected to Fabric A and Fabric B, and there will be an impairment on the uplink to the switch in Fabric B. Impairments can also happen between switches and are in that case taken care of using decommissioning of the ISL. Impairment can obviously also happen on the uplink to storage arrays, and for both uplinks to host as well as storage, it is necessary for the devices to take corrective action, and that is what we will demonstrate in this demonstration here. Here in my top left window, you can see the server. I will display the path state throughout the demo. First, I want to show you that the HBA that I'm using is an Emulex HBA. And as we talked about before, there will be impairment on the link to Fabric B. Now let's start some traffic, and on the windows for Fabric A and Fabric B, you can see the uplink port, and down in the bottom right corner, you can see the application performance running. And so what will happen is, in this example here, we don't have Fpin enabled on the Fabric yet. And in a little bit, you will see we hit the impairment and how that impacts the application. So you can see here we hit the impairment. I'm running a 70/30 read-write workload, and as we hit the impairment, a SCSI timeout is incurred. SCSI timeouts generally are set between 30 seconds to 60 seconds, depending on operating system and storage device. In this example here, we're looking at close to 60 seconds, where the application is not able to complete any storage I/O. And so basically what's happening now is that the application is halted and just waiting for the timeout to exceed. Now we see the timeout has exceeded, traffic resumes. Notice on the top left corner that both paths are still active and normal, and now we hit a link impairment again. So we obviously have some intermittent but reoccurring link integrity issue in our physical infrastructure. Now we're waiting for another timeout to exceed, and then traffic resumes again. We fall into the same pattern. We hit the next impairment, and so on and so forth. And so we run this test for 3 minutes. And now what I will do is go in and enable Fpin on the two fabrics. We do that from SANNav. You can also do it directly on the switches. It's really a maps policy action that you simply enable. So you can see here I go in on each switch and just select Fpin as a action on each switch. And now with Fpin enable, let's then go back and start again. But before we do that, I want to show you that we have a new command called fabric notifications, where you can see the HBAs that are subscribing to notifications from the fabric. So you can see here both in Fabric A and Fabric B, and we can see there are no notifications sent at this time. And we'll start monitoring the ports again where the host is connected, and then start the traffic on the server. And so we're starting the same workload. What we will see here is that we will hit the impairment, and on the first occasion we will see exactly the same impact on the application as we saw before. We will hit a SCSI timeout, but then what will happen is the fabric has now identified that there is a link impairment, and so it will communicate that to the HBA, and the HBA will then tell that to the MPIO layer. And from Red Hat 8.3 with EPEL packages, there is now support for the MPIO driver to understand fabric performance impact notifications and take a corrective action. So you can see now we hit the impairment and our application has halted just like before. It's not able to complete any storage I/O. And then as we exceed the timeout, you can see traffic resumes, but we also notice in the top left corner that now one of the paths is set as marginal and no longer used for balancing the traffic across the two fabrics. So now all our traffic is running in fabric A, and we no longer hit any performance issue. If we look at the switch here, we can see that 3 Fpin link integrity notifications were sent to that server. And now we've completely mitigated the impact of the link integrity issue. Obviously, you're alerted, and now you can take care of it in a standard maintenance window. Just in order to review, we can see here the performance profile from when we ran without Fpin and then with Fpin. The green line represents the average performance of the storage I/O, but obviously it doesn't help that without Fpin we had this very strong sawtooth effect with long periods where no I/O could complete. Whereas with Fpin we have a single occurrence, and then after that it's communicated to the server, and we don't hit the problem any longer. You can now repair the physical infrastructure and avoid the link impairments, and the problem is solved. Thank you very much for watching this demonstration. For more information, please go to Broadcom.com. Thank you.